Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Today's show is brought to you by OnPay, the new standard in payroll. You can pay employees and contractors in minutes, automate your payroll taxes and filings, as well as provide health benefits and HR in all 50 states. For more information, visit buildingthefutureshow.com/onpay. Welcome back to the show. Today we have Broc and Kevin from Wrightspeed. Guys, welcome to the show. Yeah, I'm excited to have you on the show. I think what you guys are doing is really innovative and cool. But maybe before we get into Wrightspeed, let's get to know each one of you a little bit better. And Broc, maybe do you want to give us a quick overview of yourself, kind of where you grew up, where you went to school, and how you got to Wrightspeed?
Sure. So I'm originally from Los Angeles, and I'm a mechanical engineer from Berkeley.
Oh, very cool.
And I started my career at General Motors,
okay,
where I worked in safety and vehicle validation and chassis design. And while I was there, I got to work on some pretty neat things: the parallel hybrid truck, and also some forward crash warning, and some medium duty trucks as well. And they also put me through an MBA program while I was there at the University of Michigan. And I went from there to Agilent Technologies in a leadership development program. And while I was there, the startup EV industry was starting to develop, and I decided to go be a part of it. And I joined what became Coda Automotive as their VP of Engineering and Project Management. And then from there, I wound up being the president of a power electronics division of Methode, a public company. And then I went to Qualion, which was as their director of technology. They were are a lithium-ion company making batteries for space and medical and land vehicle applications. And we were bought by Enersys, a public company. They're the world's largest industrial battery company. And I stayed on for a couple of years after that acquisition as the director of technology for their new division, covering lithium-ion technologies. And then I went and I joined a company, Divergent 3D, which is a company that was 3D printing vehicle structures. It's a really neat company, and we also developed a hybrid supercar that goes 0 to 60 in 1.9 seconds, and costs over $1 million. And it was a lot of fun, but I was really interested in getting back to something that was really focused on electric vehicles and cleaning up the environment. And Wrightspeed had been something that I had known about and had even had some interactions with when I was at Methode. And they had amazing technology and an amazing architecture for the vehicle powertrain for these heavy vehicles. And it really looked like a great opportunity to come back and work on something that would have a big impact on the environment. And so I came over a couple of years ago and joined Kevin and the team to work as the VP of engineering there.
Very cool. And Kevin, do you want to give us the same quick kind of intro, where you grew up, kind of where you went to school, and how you got to Wrightspeed?
I'm Kevin Landis. I'm the founder and chief investment officer at First Hand Capital Management. And I'm a Silicon Valley product, born and raised here, Cupertino and Saratoga. And I always tell people I had the good fortune of being born in exactly the right place in a really interesting time, and the good sense to stay put and not screw it up by moving away. So I firsthand invested in Wrightspeed about 7 years ago, and over the years we've continued to support the company. We're Wrightspeed's biggest backers and among the biggest fans. I'm chairman of the board, and we're very excited, not only by the mission, but by the investment opportunity as well. We hope to we hope to make this a double win, do some good, and do well at the same time.
Sure. So what originally drew you to Wrightspeed then?
Well, the post 2008, 2009 financial crisis, a lot of the green technologies had blown up and sort of been discredited. And we realized that there were still some good ideas out there that just needed a little nurturing. And but by then, Tesla was already starting to become a success. And we could see that there were reasons that it made sense to have an EV. I went out and bought an EV just to kind of have the experience of it and the feel for it. And I guess what we saw really happening down the road was economics. There was going to be a good economic argument. So even if you didn't believe in climate change, and even if you didn't care about pollution, it would still pencil out better to have an EV. And the reason for that was this great untapped energy source known as momentum. When your vehicle is rolling and you hit the brakes, harvesting some of that energy and putting it back into a battery is absolutely just free energy, and the economics of that can be pretty compelling. That's particularly true when you're talking about a vehicle that stops often, and it's particularly true when you talk about a vehicle that's heavy, and that's ended up being this company's focus.
Interesting. Okay, so for people that haven't heard of Wrightspeed, what exactly is it, and how has it evolved and stayed the same over the last 7 years?
Well, I'll let Broc tell you what it is.
So Wrightspeed is an electric powertrain company focused specifically on heavy vehicles. So we make electric powertrains for refuse trucks and transit buses and heavy duty delivery vehicles like tractors for regional delivery or straight trucks for delivery of parcels, for example. And we make just the powertrains and all the software that integrates those powertrains to the vehicle, as well as their controls and connectivity. And what we do is, what the system does is it allows us to, in a modular way, adapt this powertrain to different vehicles and to take what would normally be a diesel-run vehicle or perhaps a CNG-run vehicle and replace that with an electric vehicle powertrain using our proprietary axle and our battery system and having the controls on top of all of that, and then telematics and instrument cluster that draws everything else from the vehicle together to one central node. And then on top of that, we also have the capability of adding a range extender that's optional that allows us to make the vehicle a hybrid for customers that need extra range or just for some reason aren't able to have the infrastructure required for an EV.
Interesting. Okay, so for people that don't understand how it works exactly, does it have to be a brand new vehicle, or can you retrofit an old vehicle, or how does that kind of work?
That's a really great question. So, of course, it can be a brand new vehicle, and we can put them into a brand new vehicle, or we can even supply it to truck manufacturers, and it can be incorporated into their vehicles at the line. But we can also put it into used vehicles. And the really important thing to know about these heavy vehicles is they tend to last 10 to 12 years, but the traditional powertrains only last 5 or 6 years. And so, typically these vehicles go through 2 powertrains in their lives. And so we can either, upfit the vehicles at the beginning or just have them built with our powertrains to start. But there's also an opportunity to take vehicles, instead of overhauling them when they're halfway through their structural life and their powertrains need to be replaced, we repower them, putting in an electric powertrain or a hybrid powertrain at that time.
Got you. So does it have to be a specific make and model of vehicle, or can you basically do most manufactured vehicles at this point?
We can really adapt to most vehicles. Not every vehicle from every manufacturer, but we're designed to fit in the majority of models from the majority of manufacturers.
Okay. And then I'm assuming, do you have like specific pieces that need to attach to specific manufacturers, or how does that kind of work? Because they're all a bit different, right? And the layout's a bit different?
They are, but an interesting thing about the heavy-duty vehicle industry is that it's characterized by allowing the fleet operators to select what content they want in their vehicles. And so it's normal for a customer to specify which axles they want that come from a third party, which engine that they want in their vehicle, which transmission. And there's companies that make those separate powertrain parts. So it's not, unlike buying a passenger car where, if you buy a General Motors car, you're going to get a General Motors engine in that car. You can actually buy a Mack truck and select a Cummins engine to go in it,
Okay.
or an Allison transmission to go in it. And so there's some level of modularity that's already built into these truck structures.
Okay.
And so we're leveraging that in what we do. And so we have an electric axle that's designed to replace traditional electric axle, and it has the axle as well as a 4-speed transmission on it, and 2 independent high-speed motors that plug into that transmission that independently move each wheel bank. And that's all one modular piece that just goes in and replaces the axle. And, you apply power to it, and suddenly you have electric vehicle. And, you can add one axle for a vehicle that has a single drive axle, or, if it's got dual rear axles, you can just put 2 in there and have twice the power. And so we're modular in that way. And then our battery system, we specifically designed the modules of our battery to stack up and fit right between the frame rails of these vehicles. And so we can be flexible and put the right amount of battery in between the frame rails and really take advantage of that. And because our axle has the motors right on it, it gets rid of the prop shafts that normally connect the transmission and the engine with the axles. And so we have a tremendous amount of free space along that vehicle chassis to install those batteries and mount that battery system.
Okay. So do people have to get the vehicle to you guys to install? Do you have authorized people that can install it in a bunch of cities, or how does that kind of work?
Yeah, that's a great question. We've got for example, on a first customer, or on a customer on their first couple of vehicles that we're working with right now, where we're doing a couple of transit buses with them, we got a couple of their vehicles and we're installing the powertrains into their vehicles.
Okay.
And we're doing that on the first couple just to help them out with it, put instructions together about how it goes. And then they actually want to install our powertrain kits in their buses locally in the future. And so we have an agreement to put together 150 with them down the road. And we've talked about, hundreds more a year. And, but the idea is that they would just install them there based on having, received a couple of buses and knowing how to do it. And then in addition to that, we were also, in talks with and even have an LOI in place with some companies that do that kind of upfitting and retrofitting of vehicles. And but we haven't made those announcements yet.
Got you. Okay. And then I'm assuming that it takes roughly the same time to put in your powertrain as it does to kind of like the traditional powertrain. I'm assuming the time's roughly comparable.
Yeah, it's pretty similar. It's probably even faster on the EV version and winds up being similar in time when if a customer opted to do the range extender and have a hybrid.
Okay, got you. So maybe you don't have to name like customer names or anything like that, but how do you guys perform against like a traditional powertrain, and then maybe talk about how much extra they get with kind of the range extender as well?
Sure. So if you look at the efficiency of our powertrain, we really have an extremely high efficiency, and we do that with our rear axle by having these high-speed motors mounted to a 4-speed gearbox. It allows us to make sure that the motors are always in their sweet spot. They're always in their optimal operating point, and that's especially important when the vehicle's stopping and starting, as Kevin pointed out. And our first gear tops out at about 5 miles an hour. And that ensures that our vehicle, both when it's accelerating and when it's decelerating all the way to a stop, is really going across the most efficient region of our motors, so that we're recovering the most energy possible when we're braking, and that when we accelerate, we're being very efficient as we accelerate from 0 to 5 miles an hour and beyond. And so that electric axle allows us to be extremely efficient, whether we're an EV or a hybrid. And the easiest way to explain the comparison of the efficiency of the vehicles is to compare the hybrids.
Okay.
Our hybrid system to a traditional diesel, because then it's sort of apples to apples of how much fuel you put in.
Right.
And we did modeling that showed over 50% fuel savings on refuse trucks. And then when we actually did our field testing in the North Bay, we saw even better fuel savings than that. It was over 60% fuel savings on a pretty aggressive route. And that fuel savings is huge, right? And you think about the airline industry, they spend a lot of money on aircraft to get the newest, most efficient aircraft, and it almost doesn't matter how much those airplanes cost because the fuel savings is so important. And it's similar in these heavy trucks, and the fleet operators understand what's most important is the total cost of ownership. And we've really optimized our system to be the most effective in terms of total cost of ownership. And, the other thing I'd point out is that, whether it's the EV variant or the hybrid variant, that, our system's very efficient and creates that saving.
Sure.
And then the savings exist both as a fuel savings, but there's also a maintenance component to that. EVs, as everyone knows, are much better from a maintenance perspective, but also a big component of maintenance on these heavy vehicles is the brake jobs and brake pads themselves.
Right.
And so, it's normal for example, a refuse truck or some of these heavy vehicles doing stop and start to replace their brake pads every 2-3 months. And with our system, because we're recovering all that energy into the battery instead of putting it into the brakes last a lot longer. And there's a big savings there as well. And so, it could be as high as, a $40,000 a year savings between the fuel and maintenance savings.
Interesting. Well, and then you mentioned earlier quickly, you guys also tie into software. So I'm assuming that you can let people know, because obviously, like if I'm driving a truck up and down hills all day long, it's probably going to wear out quicker than if I'm just on a flat surface. So you can predict and tell me when I need to do maintenance on certain things, or how does your software integrate with the actual components that you guys put in a truck?
Yeah, no, that's a great question. So in addition to making these systems that make the vehicle work and do the heavy lifting of moving the vehicles around, we also then have this centralized computer for controlling all of these systems. And we tie in all of the original systems of the vehicle as well. And because we do that, we have all the data in one hub of the vehicle, and along with GPS information and a telematics that allows us to connect to our back end. And so we have a database of everything that the vehicle's doing. And so with our system, we can look at, where the vehicle is, how much energy it's using, and you can get that information not just for a total route, but you can look, right down to the block level or the house level, how much energy is being used along the way, and look at opportunities and analytics to make improvements to how things are done and what's being achieved. And one thing that allows us to have a deeper understanding of that is that we're not just buying off-the-shelf axles and motors and putting them together as an integrator. We actually are the developers and manufacturers of those subsystems. And because of that, we have access to all of the sensors, not just on the vehicle, but also into the motors, into the axles, the batteries. And so we have all the vehicle information, and we've written all that software and own all that software. So we have all the data right down to the base of the vehicle. That allows us to really do a deeper level of analysis than would be possible otherwise, and really make the vehicles better over time. So as we collect data on a route, on a vehicle, we can make that vehicle better, but that information also helps us make the other vehicles better, and update software over time and make improvements over time.
Sure. Well, and like I mentioned to you guys before I started recording, it's like I built a bunch of these like fleet management software, and some of the hardest challenges, it isn't actually the software part, it's the integration of the hardware or of the actual like different pieces of the vehicles, because they're all made by a bunch of different people, right? And it gets costly to figure out how to integrate with this and that piece and this piece and that piece. But with you guys control the whole thing, right? And so it's so much easier. And I think probably a lot of your customers and potential customers probably don't get that off the start, like how much or how valuable just that integration alone is. Is that fair to say, or what are your thoughts around that?
It's absolutely fair to say that our integration of our modules allows us to have that information, and that's much easier than if we were trying to link together a bunch of hardware from other suppliers. And so we definitely have that advantage, and it helps us out a lot. I'd say that our customers are quite sophisticated in terms of their understanding of the importance of the data.
Okay.
And
that's great.
They're already doing some level of data analytics and will appreciate what we have. And what we offer them is a deeper level of data analytics than they currently have today. And so they'll be able to get more information than they currently get. And in addition to just providing the data so that they can have access to the data, we also have the ability to support them with analytics.
No, very cool.
I think that's really well said. The thing that the customers all understand is that it begins with capturing that information. And we understand that. And if they want us to just give them that raw information and write their own software and have their own secret analytics sauce, so be it. And if they want our help with that, no problem at all. Whether you're talking about big data analytics or you're talking about an AI engine or however sophisticated you want to be, none of those things work unless you've captured the raw data to begin with. And we've kind of kept that in mind all the way from the ground up, that we'll serve up the best data to you and serve it up in whatever form you need.
Sure. So is the cost comparable to traditional kind of powertrains, or you guys, or where are you guys kind of in the cost space?
So the vehicles do cost more upfront, but when you look at a total cost of ownership, there's a tremendous savings to be had over the life of the powertrain. And so regardless of what type of vehicle you have, it is a cost benefit to use our system and to replace a diesel vehicle. So this will cost less. It's just like when you buy an EV, you're paying for some of the gasoline offset up front. Yeah. And the total cost of ownership is positive for results in a savings for our customers. When you look at how much it is, it depends on what the application is. But one of the better applications are the transit buses, where the vehicles are often stopped and are in traffic a lot or stopped at the bus stops. and in those applications, our payback period is 2 years.
Oh wow, so it's pretty quick.
They'll have a cost benefit. Yeah. It's a little larger on some other applications. It can be 4 years on some vehicles that stop less and have double axles. But either way, it makes financial sense for people to be using our system.
Okay, no, that makes total sense. You mentioned? Well, I guess can you swap out the battery packs on the side of the road, or is it kind of no, you can't really do that, or how does that kind of work?
We don't see a need to swap battery packs.
Okay.
You can charge them fast enough that it just makes sense to do fast charging of the packs.
Okay.
And have enough range in the pack so that they can finish their objectives. For customers that are doing longer range runs, and it makes sense, we can also add a range extender, which really alleviates any concern about being able to finish their drive cycles or their routes.
Right. Okay. No, that makes sense. So how do you guys see this space going? Because it seems to me, and especially in certain countries in the world, they're basically passing legislation that everything has to be some sort of like non-gas, non-diesel vehicle by a certain year in the coming future. It seems like basically everybody in the world eventually will be running some sort of electric vehicle. Is that fair to say, or what are your thoughts around kind of the future of the space?
I think
legislators are good at setting policy, but they can't mandate economics.
Sure.
So the key thing here is that it's welcome that we get regulatory help, and that politicians want to give this a little bit of a push. But really, the thing that's driving it is the economics. And
sure.
The fact of the matter is, once you show how fast these things pay for themselves, and once you show how much they can actually save money and maintenance costs and lots of other things, once you show a garbage truck operator that he's going to get fewer complaints about the noise of his trucks because these are going to be a lot quieter, all of these things are going to make them want to do it anyway. So don't think of it in terms of the people who control of public policy are going to drag this industry kicking and screaming that way. No, the technology just keeps getting better. And this is maybe a jump start, giving the industry a jolt and really encouraging people to, do those first few evals. But really, this is going to happen anyway.
Interesting. Broc, you were going to say something too, I think?
Oh, that was spot on. That's exactly my sentiment on it.
No, interesting. No, I agree. I think it's just a matter of time, right? And you're right. It's nice that, policymakers want to do this, but yeah, if it doesn't make economic sense, nobody's going to do it, right? Or if it's not cost effective for the average person to buy it, it's just people aren't going to buy it, right? It's interesting. So I'm curious though. Do you and correct me if I'm wrong, I was reading somewhere a while ago that battery technology hasn't really changed a lot in the last 100 years, but it's gotten a lot better recently and it's about to get a lot better. Is that correct? Or what's the state of kind of batteries, and are we going to get the really, really long range that we've kind of always hoped for and expected? Or what's the state of the battery space right now?
The batteries keep getting better, and we're using off-the-shelf cells just like all of the other integrators and manufacturers of these kinds of systems, and that allows us to improve as the cells and chemistry get better over time. And we've seen it. I mean, there's no official Moore's law for the energy density of lithium-ion batteries or batteries in general as the chemistries advance. But what we've seen is that the energy density of the cells has been approximately doubling every 7 years or so.
Oh, wow. Okay.
It looks like they keep on improving, and so as the cells keep getting better, the chemistries keep improving, and the energy densities get better, we're going to see more and more range in these electric vehicles and better performance of the vehicles over time.
Sure. No, that makes a lot of sense. So I'm curious though, do you think that like a technology like you guys are building could ever make its way into kind of consumer cars, or you guys just really focused on the bigger, large trucks?
We're really focused on this heavy duty industry.
Okay.
It's really the important place to be focused. There's plenty of people that are making really great passenger car, EV, and hybrid solutions. But when you look at the heavy duty vehicles, it's a whole different set of problems. And, something that people don't realize is just the amount of mass and power required to move these things around. You see these vehicles and they always look like they're moving a little slow and they're not doing anything too aggressive, but there's more power associated with one of these trucks going up an off ramp than you see in a fleet of cars going around a racetrack. So we're really adapting our system to be the perfect thing for these heavy trucks, and really the benefit to the fleet operators is huge. But the benefit to the environment is really significant as well. I mean, one statistic that's important is that these heavy-duty trucks make up only 4% of the vehicles on the road, but they account for 30% of the emissions produced of all on-road vehicles. And so there's really a huge opportunity here to have an impact on the environment in a positive way.
Sure. So how do you guys deal with changing weather conditions, especially in colder climates? Have you guys had to deal with that yet? Because as far as I understand, and I could be totally wrong here, it's like battery technology doesn't have as big of a range in middle of the winter in in a cold place as it does obviously like in a warmer place like California. Is that correct? Or how do you guys solve that problem? You just use the hybrid model or in those locations, or how does that kind of work?
Our batteries tend to do really well in both hot and cold because we have a pretty sophisticated thermal management on our system.
Okay.
So the environmental conditions don't affect the battery that much. The place where you'll see an impact on range is on buses, where you have to provide energy for the heating and cooling of the cabin, on hot or cold days. And so there you can see a reduction in range, and it's important to do things in an efficient way for both heating and cooling of the cabin. And, in some areas and some conditions, it would make more sense to just add a range extender if people wanted, or we can just carry more battery is the other option.
Okay. No, it makes sense. And then what about, because I don't know a ton about it, but I know in colder climates, like traditional diesel trucks usually just like stay running for hours on end when it's super, super cold because they can't shut off because they won't start again. So like, how do you guys solve for a problem like that? Because obviously you're not polluting the air if you have to keep your car running, or do I not have to keep my truck running because I have this EV solution? Or how does that work?
Yeah, that's a huge benefit of both electric vehicles and hybrids is that, when you don't need the power, you can just turn the engine off and be running the accessories straight from the battery and, be still providing heat to the cabin and, have the vehicle ready to go and then start the engine when you need it. Or in a full EV, when you're stationary and you're just obviously not putting any energy into the motors. And so that's a big component of the savings.
Interesting. Yeah, because I think a lot of people like outside of the industry probably don't realize how much pollution is happening just when the truck's just sitting there, right? In certain parts of the country and the world, really.
Yeah, it's
right. And you know what? The big insight there is, think about a car commercial. When I see a car commercial, I see, well, first of all, it's always wet pavement, but for some reason. But I see cars going 0 to 60 and people's hair being blown back. And then I see a car on cruise control in some lovely freeway setting. And you'd get the impression that that's all anybody ever does. They go 0 to 60, and then they hit cruise control at highway speeds. The real world isn't like that. In the real world, there's starts, there's stops, there's traffic, you're speeding up, you're slowing down, and that's really complicated. And I guess maybe that's the difference here, is that almost all of our engineering trade-offs are made with an eye towards what actually happens in the real world, and that's where you're going to get the benefits of ownership.
No, I think that makes a lot of sense. But we're kind of coming to the end of the show, so how about we close with mentioning where people can get more information about you guys and any other links you want to mention?
Well, I guess we have one of those websites, so you could go to Wrightspeed.com and see a little bit about it. There's not a lot of info about us right now because we've been pretty stealthy as someone who was early to the market, but more and more you'll see it on our website.
And it's with a W, like right with a W, speed.com, just so people know.
Correct.
Well, guys, I really appreciate you taking the time out of your days to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day.
Thanks so much.
Thanks, guys.
Thank you.
Okay. Bye.
Yep. Bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.